Hi everyone, this is part 2 in our space shooter tutorial. In the last tutorial we kind of left off here with our cube player object and setting up a pretty cool third-person camera script. Worked pretty good. So in this tutorial what we really want to do is set up complete uh, player control. So a player control script. And we want to do a few things with our scene before we start on that. So what I'm going to do is I'm going to add a GUI text object into the scene by GameObject, create other GUI text. I'm just going to align it to the middle. And I'm going to push it up towards the top of the screen. And I'm going to name it. And we're just going to call this engine power label. And basically what this is going to do is this is going to read out the strength of our engine power, which kind of comes in handy in some types of games. So the next thing I want to do is add in a directional light, just so we have like a light source to see our player rotating around. I'm going to zero it out and leave it up here nice and high. We'll add some shadows, and let's just give it a little bit of an orangish hue. Let's assume that it's the star, the sun, right? So we'll call it sun, right? Pretty pretty obvious. So what we were doing before is our our camera script, our third-person following script, was actually following this root player object, and really that's not very versatile, and we want to do something that will allow us to kind of adjust a target within the player that the cam can follow. Maybe we even want a script moving that around or something. So let's just go GameObject, create empty, and hit this little gear up here and do reset. And reset the transforms. Let's drag it into the player, and let's name it cam target. So now our player camera, instead of following this root player item, let's have it lock on and follow that cam target thing. We could actually move it up here, and I'll show you what this means. So we have our player moving in the world, and it's following that. Okay? But if we want to offset where the camera's following, kind of like lower, further behind, right up on it, even maybe over the shoulder, then this gives us a lot more versatility to kind of adjust the target within the player. So we're going to go with that setup for now. Okay, the next thing we want to do is we want to separate the artwork from the collision and all of that. We definitely, on this root object, we don't want to have collision and all that on the root object. So let's just remove that component, remove the mesh renderer, remove the mesh filter, and what we have is basically what you would get if you create a empty game object. Okay, clean root. It's got a camera target inside. So what we're going to do is let's go GameObject, create other, and cube, and hit this little gear and reset it. And so our player's back. But now the player root is nice and clean, and our artwork is inside. So what we'll do is we'll hit Control D and duplicate it. We're going to make one of these cubes artwork and one collision. So let's remove the collider off this one. So now this is just an art mesh, and this is a collision mesh. So we need to get the renderer off of the collision mesh. So now we have them cleanly separated. With that done, let's clean up our hierarchy a little. GameObject, create empty, drag it into the player, hit the little gear, just reset the position. And we can rename this object colliders. Okay? Let's duplicate it, and let's call this one artwork. So let's take our collider, drag it into colliders, take our artwork, drag it into not into the cam target, into the artwork node. So now the artwork is held in that container, and all collision is held in that container. What this allows you to do is basically drag in your own 3D models into the artwork and then go into this colliders option area here and just scale and move all these different colliders. Hit duplicate and scale them and get the shape of your aircraft with box colliders to match what's in the artwork folder. So what we're going to do is I'm going to make something that looks like wings. Oh, picked the wrong one, sorry. We'll go off the artwork. So, obviously there we go. Oh, this is one rough looking spaceship, but hey, you get the general approximation, the general idea. I'm going to hit Control D on a cube, bring it down here into colliders, component, physics, box collider. We're going to remove the renderer, and now we just have a collider for that, and the art's up here. So we can hide the art, and you'll see the colliders. Okay. And obviously our one collider doesn't match, so you want to match up your artwork. See, you have your artwork mesh. It doesn't really line up very well. So let's go ahead and I personally like to give a little bit of a buffer around the collision from the art so that other things don't actually interpenetrate the artwork. So there's our collision. Easy peasy. There's our artwork. And it's all cleanly separated in this hierarchy, and there's nothing on this player. So this is and there's the camera target. So this is a really let's actually move the camera target back down. There we go. This is a really cool way to kind of separate everything neat and cleanly in your hierarchy. Now would be a good time to hit Save Scene and Save Project. Now we want to go over here into our project view and right click, create a folder, call it Prefabs. Over top of that, we'll right click again and go create prefab and call it player. Now we can just left mouse grab and drag over top of it and apply what's in the scene now as a prefab. So we can always just drag it back over and we have everything. So we have this prefab. If something were to happen to the scene or the scene wasn't saved, the prefab would always be in the root of the project, saved and able to be accessed. So it's really great to have it that way, to have things prefab. So with all of this set up, we have our engine readout text, we have our new updated player prefab in here all set up ready to fly, but we don't have a script to control it. So let's go in our scripts folder and go create C#, and we'll just call it player control. That works. And we'll let it sit here and finish compiling the empty script. Let's go to our player, left mouse drag it on. We'll hit apply to sync the prefab. And let's double click this open. Okay, so we have a clean empty script. We went over some variables earlier, so we're not going to obsess over the details of script and everything. But as you follow along, I'll describe a few things and we'll explain it that way. So as we saw in the last script we wrote for the camera, we had public and private variables that we could adjust in the inspector. So the first one we want to make here is going to be a public one. It's going to be a float type, and it's going to be called max turn rate. And I'm going to set a value of 1200 for it. And that's from my own personal testing. I found that that turn rate worked well. So when I save it, Control S, come in, now we have a variable for the turn rate in there. Okay? It's public, so it shows in the inspector. It's a float value, so as you see here, I can go to all kinds of crazy, like, we can go to all kinds of crazy decimal point values. Okay? We need a wide range of values for that turn rate. So the next one will also be public. And we'll call this, well, it's a type of vector 3. We'll call this max impulse. and we're going to give it a value, well, a few values. We're going to say new vector3, 10f, 10f, 700f. There we go. Now vector3, if you remember from the camera tutorial, is just x, y, and z. It's pretty much the same thing as this x in the position and this. This is the position. The vector is where we're going down that position. So think of it as, if we're looking at our player object here, this little blue arrow and the blue arrow coming up there, that's the vector for z, for the z-axis. That's the vector that way. Vector forward, transform forward. The x is transformed right, vector to the right, and then vector up, which is the green y. So all three axes. So this is max impulse, and we're saying, okay, let's give it some values, 10, 10, 10. In x, let's go with a maximum of 10, and 10 in y, and then down the z, which is going to be pushing our aircraft forward, let's go 700. And those are the vectors for those. So the next variable we're going to do is going to be another public vector3, and we're going to call it velocity, and we're going to say vector 3.0. Now vector 3.0 is identical to writing, and this is going to be mind-blowing, but not really. So vector 3.0 is identical to writing this 0, 0, 0. It was like programmer shorthand for a series of vectors that have all 0 values. And this is our velocity, so we're going to track down each vector the velocity that we're moving for that vector. Okay. The next float will be public float, which is a floating value. We need it to go from smoothly from a top value to a lower value. It's going to be called impulse sensitivity, and we're going to say a value of 500. Now I put the little f behind the values just to let the script know that it's a float and not an integer, a 1, 2, 3, or 4. You know, it's a floating decimal point number. Impulse sensitivity is going to be the sensitivity of our impulse. Basically, if you think of it like in Star Trek, where their engines had an impulse power, and it was like 100%, or it was 0%. So, yeah, the impulse sensitivity is going to be how rapidly we change that. Okay, so the next one is a public, where am I at? Public float, and this is going to be turn sensitivity, and we're going to give it a value of 1200 to start. Now these values are just values that I found worked when I tested it. And turn sensitivity is like the impulse sensitivity. It's like how rapidly can we turn, how sensitive will the turning be. Okay, the next two I'm going to kind of separate different blocks because these are different types of left exhaust effects. And then I'm going to select it, Control C, Control V, because I don't like carpal tunnel and I don't like typing. So what these are is these are publicly exposed in the inspector, and we go over here. Oh, I got a typo. Yep, missed the 3. I'm going to hit save. Okay, so there they all are. Okay, we can track and see what our velocity in the x-axis is. We can see it in the y. We can see it in the z, and the same goes for our impulse. These are the sensitivity values for our turning and our engine impulse. And then this is where it's asking for the particle systems, which we don't have right now, but are very easily set up. Let's expand our hierarchy. And let's go game object, create empty, drag it into our player, go to little gear, reset it, and we'll call it visual effects. This is going to be a container for our particle effects. So let's go game object, create other, particle system. We'll drag it into the visual effects. Okay, let's just bring it up a little bit, bring it over, and then rotate it so it's shooting out the back. Now I snap rotated that, and I held down Control and dragged on the axis, and that's a snap rotate. It allowed me to get it pretty accurate. I'm going to go in here and zero out some of these crazy values occurring. I don't know what that. It gets these embedded values. So weird. Anyway, I like to even everything out. I like those values for where it's sitting. So we're going to call this the left exhaust effects. Control D on that. And let's just take the negative for this one off of that, and it should go exactly to the right side in the same exact spot. So we'll go right exhaust effects. We have them on the right and the left. I'm going to do something cool here, a nifty little Unity trick, and just disable the right one, and we'll only work on the left one, and then we'll take all of the values of the work on it and just copy them right onto the right one. So I'm going to change the duration to 1. I'm going to change the start lifetime to 1, the start speed to 2. We're going to make the max particles something mobile friendly, 50. We're going to go to emission, change that to 25. So constantly over time we're emitting at least 25 particles. We're going to go to the shape. We're going to change its angle to, let's see how low we can go. Oh, that's good. 1 and 0.01. So we got like a steady stream coming off the back. It looks like sort of like engine exhaust. I don't like the scale, so I'm going to go down with 5. I think the lifetime could be a little shorter. So 0.5 on lifetime. Or could be a little longer. 0.7 or 6. Okay, so those settings are good. I'd like the size of the lifetime. I'd like it to actually get a little smaller, like it's wisping away. So let's experiment with the size. Okay, not quite that tiny. That's good. I like that so far. So there's the size. Color. I don't like the current color. So the way the color works, the bottom is the color, these bottom tabs, and the top color is the alpha. So what I usually do is at the very end it fades out, so it's 0 alpha at the end and at the beginning. Just clicking up here will allow you to bring a new alpha up top. So what I'll do is we'll go with that. And I lost my little window. So what we need to do is we'll set some colors. It's kind of cool, that works. I wasn't really going for actually I have it inverted, I guess. I don't think a spaceship exhaust would look like fire like this. It would be some kind of cool, like, space age looking color, blues and purples or greens, like something very high tech. But for the brevity of this tutorial, we're going to do it this way. So I have everything I like on this set how I like, so I'm just going to right click over it, call copy component, select the right one, we're going to enable it, and right over this component we're going to go paste component values, and look at that. Double our money for a single amount of work. So there's our visual effects. Let's hit apply, And we have the left particle, the right particle. So on our root particle, on our root player now, we can go and drag in the left effects. We can drag in the right effects and hit apply. And now they're part of it. It's pretty cool. They don't simulate when they're not selected, so it's just kind of like they're frozen. So when you see these two particle effects, we're going to control these in a little bit, and we're going to change like some scale and size on them so that when the engine gets going and the plane's really going, the spaceship gets going, they'll scale up, they'll be longer in scale, they could change color, any kind of amount of awesome things, but you'll see how we do that in the script later. So that's those two variables. Those are all the publicly exposed variables that I want to leave on here that we can go and set and play with. This is the max impulse we could have. This is the sensitivity of turning an impulse. This is the max turn rate, the angle of the turn. Let's save scene and save project over here as we go, and just make sure we hit apply and the prefab is applied. Okay. And so now we'll move back into the script, and these are all the public variables that we wanted exposed in the inspector. All these other ones are going to be these more complicated variables that are privately hidden because they're used in calculations internally by the script. So vector3 impulse equals vector3.0, and we just learned that vector3.0 is just a zeroed out vector3. This is going to be the vector of our impulse. Where's it coming from? Is it coming from the left side, the right side, behind the vehicle, and impulsing it, moving it forward? The next one's going to be a private float, and it's going to be the desired impulse, and we'll just set it to 0 by default. The next one will be a private vector3 impulse actual equals vector3.0. The next one will be a private float again. That's not right. Max impulse change, we'll set it to a value of 100. I've tested this before already, so I know that it works. Another private oh, I hit the caps lock keys, that's not good. Another vector3, which is going to be the turn rate, and we're going to zero that out by default, 0 values. The next one is a private float, which is going to be the desired, not spelled like that, desired impulse input. And we're going to zero out that value. I'm going to explain all of these really quickly as soon as we are done typing them in. I just want to kind of get them out of the way. Desired turn X input. We're going to zero that out. We're actually going to select it, Control C, Control V, and set that one to Y. That's the desired Y input, X in, turn Y input. Only got a couple more. Desired input X. We're going to zero out that float value. Private float desired input Y, and we're also going to zero out that value. Another private var, and it's going to be a transform component, and it's actually going to be the transform on this object. We're caching that transform again. Okay, so let's go up and explain a few of these. So we told you that the impulse was basically the engine power down a certain vector, going down Z left or right. Desired impulse is going to be the impulse we actually want to be at, we want to get to. Do we want to be to 100% speed? Impulse actual is going to be, well, we're on our way there, but we're not quite there yet down that vector, but we're going down it, towards it. Max impulse change is going to be kind of like the engine torque of a car, how rapidly can we go from our actual impulse currently to the desired one? How fast can we get to 100% engines? The turn rate is a vector 3, so it's like x, y, and z points in space. And it's just saying, so what vector are we going to turn down? And by default it's set to 0, but we'll adjust that later in the script. The desired impulse input is just going to be really the input from the keyboard. The W, S keys, the up and down arrows. This is the input. This is the input that we're desiring the impulse to get to. And then there's a desired turn input on the x-axis, which is going to be like the let's see, y is horizontal and the x is vertical input from the keyboard. So left and right arrows, A and D keys. And these are the desired input values. The keyboard will actually change this value from -1 floating all the way to +1. Desired turn. And then desired input x is going to be a raw value based on this. It'll be calculated later and you'll see it. And this transform, we're just going to cache this actual transform of this player. So let's type in a couple more. We only have a couple more variables, just like I think 3 more. And so the next one will be a public float engine power value. Oh, I can't type. Engine power value. And we're going to make that one zeroed out. It's a float. It's as it sounds. It is actually the value of the engine power. Like, so are we at 100% engines or are we not? The next item is going to be our GUI text object. And I did that wrong. Engine percentage text. That is going to be this, the engine power level of it. When we're at 100% engines, it's going to say engines 100%. When we're at 10%, it's going to say engines 10%. It's going to use this text to read this engine power value, if that makes sense. Okay, last couple of vector 3, last couple of variables here. I'm going to call this one velocity, and we're going to do some get and setting on this. So velocity. Okay, we're going to get that and return that velocity. So that takes care of velocity for that. And then the last variable we have here will be a vector 3 for overall impulse. And we're going to get value. We're going to return impulse. Okay, close that out with the brackets. And then we're going to set some impulse values, and we're going to clamp them when we set them in here. And clamping is just a fancy sounding word for we're going to limit the minimum and max values for the impulse. So let's just do impulse x equals math f clamp value dot x dot 0 max impulse dot x. Okay, so we're saying impulse on the x-axis of that vector. We're going to clamp that to value x, which we're going to set down below later for the x-axis. We're not going to do anything with the y. And then we're going to clamp it, the impulse for z2. Well, wait a minute. Math f clamp. Okay, so it takes this value and clamps it between 0 and the max. I'm sorry. We're going to set this value later on down in the script. So it's taking this value and it's saying this value can be no less than this, no greater than this. And then it's saying this equals that. So we're going to select the line, Control C, Control V, Control V. We just need to do it for each axis, X, Y, and Z. So let's just go down, 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 and we're got little red squigglies, so we need another bracket. I'm going to hit Control S and save. So if you needed to look at that, that is what's going on there. I'm just going to type with it zoomed in like this. We'll go back. Now you're not going to see any of these variables showing up in here because they're all for internal calculations. But basically, we're done with all of our variable settings. So what we want to do first and foremost is we want to take this, because we're going to be accessing the transform of this player object to move it around and rotate it and all that. So we want to cache it up front by using this transform. I'm going to copy that in start, and we're just going to say that everything in this script that uses this transform is going to be equal to this transform component here. This is caching the transform up front. It's very smart to do that, because down here in update, I don't want to get too off track, but you could do transform. No, it auto-completed that for me. Wonderful. Rotate, blah, 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 some value. Okay. And what it would be doing is it would say, oh, this update is called once per frame. This function or method here runs every single frame of your game. So if we were rotating something or pushing it or moving it along, putting in just transform like this just says, oh, every frame of your game, look for this transform up here and push it or pull it or rotate it. It's seeking it out constantly. Whereas if we go up here and we use this transform value, we've cached it up front, so it doesn't have to seek it. In the start method, or start function, which is only run once, it's run when you hit the play button in Unity, it runs that one time, and it says, alright, that transform is equal to the transform on this object, on player control. This variable took a transform. So every time we just reference this transform down here later, it doesn't need to seek the transform component anymore in update. It just references the cached one that we didn't start. Start runs only once. It runs right when the game starts up. Once it completes what it's done, it's done. Okay. Alright, so we don't want to go into update yet. So after our start function here, we want to do another function or method on here, and we'll call it on engine power change. And I try to name it appropriate so that we know, well, this is stuff that's all going to occur when something changes with the engine power. So what we're going to do in here is just ask a question. We're going to say if engine percentage text is not equal to null, then do something. Else, do nothing. Okay? Okay. So in this function, we're saying, all right, if the engine percentage text is not null, which is actually yeah, okay, yeah, it's not null. So to explain what null means, let me just save our script. We'll go down here. Now null means this slot's empty. We don't have anything plugged in for this GUI text, so when it wants to access it, we're going to get an error. If it tries to change the text value or read out, because it's trying to access it, but it's null, or it's empty. Think of null as empty. This slot is not filled. We haven't actually done this. When we do this and it's filled in, that's actually not null. Okay, but right now it's null because it's empty. So I'm asking, when we go to something changes with the power of our engine, is that engine percentage text plugged in there or not? I'm saying if it's not null, then do something. That means it is plugged in. So what we want to do is say, oh, value. We want to say that the engine power value is equal to desired impulse max impulse z times 100 divided by 100 flipped. Okay, let's make sure we name that engine. Yeah, that is the engine power value. Okay, so if there's been a change with the engine, like we're accelerating or doing something, then let's grab what the engine power value is or calculate it. And we're saying that, okay, let's divide that max impulse down the z vector by our what impulse we want to be at. Let's multiply it by 100, take all of everything that's inside these brackets, and then divide that by 100. This is going to allow us to calculate a percentage from 0 to 100%. Otherwise, we would get a weird readout that would go into the thousands and stuff like that for the power. Okay, so then let's update this engine percentage text. Let's give it a value and say it's text property. On a GUI text or UI label or something like that, it's always its .text property. And say it equals some strings. And strings are just words, and usually they go in quotes like this. Okay, so we'll say our first word is engines. We want to add some more words to it. Actually, we want to add a gap, a space, empty space, between the engines and the percentage. And then we want to add it to a calculated value, which is the engine power value times 100 to string F0. And then the last bit of text we want to add to it is just a little percentage symbol. So we see the 100%, 10%, and then a semicolon to finish it off. Okay, so we're saying that the text of that GUI text equals engines plus an empty space plus some math here on this engine power value to calculate a value that we're going to send to string, which is going to say, hey, let's take this float value and turn it into a numeric word that we can read. Because a float you can't actually read out like a string, but when you write to string you can. And then this F0 in here in the parentheses on the toString is just an internal thing in the toString that helps me truncate the amount of decimal places so that we just read a solid 100% and not like 100.1%, or some weirdness like that. It just keeps all the decimal place points to three whole numbers at 100%, two whole numbers for less. Okay, so Control S. We actually should see, well, I lied. If we hit play, we don't have the engine percent text drug in there. But the cool thing is our game is still running. It hasn't run an error or an assert. It's not paused. It just doesn't update the text. And that's because we put this if is null check in there. Now, if we remove that, we just remove some of these brackets. So all we have is this calculation going on, and then it wants to update the text. Watch what happens now if it's not assigned. Game-breaking bug. Oh, well, that would help if it caught my save. Okay, it's compiling. So hit play. Oh wow. Oh! Okay, so I've created this custom function, but we're not calling the function or otherwise telling the script to run it. Custom functions like this do not just run. They don't run at all in a script when you make them. You have to do what's called calling the script. So what we're going to do is we're going to go down here and update, because update is run every frame, and we simply do that. We type it out like that to call that function. So now every frame it's going to run up here and say do on engine power change, do on engine power change, and we needed to do it every frame because it is a value of the engine power, and the engine power could change in an instant. So now that we're calling the function, let's go back and see what happens when it's called with the object not assigned. Boom, it's paused. And no matter how much I try to unpause it, our game is broken and frozen, and it's bitching with errors. The variable of the player text has not been assigned. You need to assign it. Well, that's a game-breaking bug. So now I'm going to go back in and uncomment all this, and then I'm going to go back to calling the function and update. Now you see the power of this if engine percentage is not null. That's the only time it's going to do these two things inside this function, and that's a really powerful thing when it comes to scripting. So now if we go back in here, okay, nothing happens even though the GUI text isn't assigned. The game still runs, we could still push the player around and play, and we'd be good to go. So we're checking for it being null, and we're only accessing it if it isn't null, but it's null now, so we're not accessing it. So if we were to drag it in, apply, and then hit play, it'll work. Now you see that properly what we were calculating right here. You see it happening in real life right there. Well, the real virtual world. So now would be a good time to save project, and save our script. Okay, and so what are we doing? What are the next thing we want to do? I tell you what, just to keep the brevity of this video short, I'm going to clamp it off right now, and we will put the second half of the player control script into the next video. I like to keep the videos short enough, but so look for part 2 on finishing up this player control script.